In this video, we will talk about problem solving related to derivatives. So let's moving toward the first problem. Here is the function y is equal to natural log of e to the power x plus e to the power minus x, and we're interested in finding the rate of change of this function. So d by dx of natural log of e to the power x plus e to the power of minus x, we will use rate of change of natural log of x, that is equal to 1 by x, which means that 1 by e to the power x plus e to the power minus x. Then rate of change of e to the power x plus e to the power minus x, 1 by e to the power x and plus e to the power minus x. Then rate of change of e to the power x is e to the power x, and rate of change of x is 1, so we don't need to write it. And e to the power minus x, rate of change of this is e to the power minus x into minus 1. So this will be e to the power x minus e to the power minus x over e to the power x plus e to the power minus x. We can also write it as minus 1 by e to the power x in order to make the power positive. Then all we have to do is just take LCM of it. It will be 2x minus 1 by e2x plus 1, because ex and ex will cancel out with each other. So this is the rate of change of this function. We have used formulas, that is, we have used the rate of change of natural log of x, that is 1 by x here first. Second that we used is the rate of change of exponential function e to the power x, that is e to the power x. And here we have used the theorem, that is the addition or the summation theorem. So all of the rules are used in order to make the differentiation more easy and clear. Now heading toward another example. The other function is y is equal to x plus 1 raised to power x, and we have to find the rate of change of this function. So the power of this function is not a constant, which means that we have to apply natural in order to solve it easily. Now by using the properties of logarithmic function, this x will comes down and this will become x natural log x plus 1. Now we will apply d by dx on both sides. So d by dx of natural log of y will be 1 by y into the rate of change of the function which natural log is applied. So dy by dx is equal to, so there are two functions, first is x and the second is natural log x plus 1. So we will apply product rule here, that derivative of the first function x, so dx by dx is 1, the second function as it is, and plus first function as it is, and rate of change of the second function, that is x plus 1. So this is 1 by y dy by dx is equal to natural log of x plus 1 plus x, and by applying the derivative on natural log x plus 1, this will be 1 by x plus 1, and then d by dx of x plus 1. So 1 by y dy by dx is equal to natural log of x plus 1 and plus x by x plus 1, dx by dx is 1 plus 0 because 1 is a constant, so there is only x by x plus 1. We have to find dy by dx, so taking y on the other side, y into natural log of x plus 1 plus x by x plus 1, and y is x plus 1 is to the power x, so we will write it as x plus 1 to the power x and natural log of x plus 1 plus x by x plus 1. So this is the final answer, the rate of change of this function, and we have used the rate of change of natural log, that is 1 by x. Also we have used product rule and nothing else here. Let's moving toward another example. So the next example is y is equal to tan of sine e to the power x squared, and we have to find the derivative of this function. So differentiate this function tan of sine e to the power x squared. We know the rate of change of tan x is equal to secant squared x. Here x is sine e to the power x squared. Then the rate of change of the function on which it depends, that is d by dx of sine e to the power x squared. This will be secant squared sine e to the power x squared into the derivative of sine x is equal to cos, and also the rate of change of e to the power x squared. We will get secant squared sine e to the power x squared into cos e to the power x squared. Then the derivative of e to the power x squared is e to the power x squared, and then rate of change of x squared. So this will be secant square sine e to the power x squared cos e to the power x squared ex squared and 2x. And this is the final answer. This is the rate of change of this function. And we have used the derivative of trigonometric function, that is tan and sine. Also we have used the derivative of exponential function e to the power x squared, and also we have used the power rule on x squared. So this is the next really threatening example that was considered as really threatening, but eventually it is not. So the function is y is equal to natural log of x to the power natural log of. So the first step of solving this problem is taking log on both sides in order to solve this function, or in order to handle with this type of power. So after applying the log, natural log on both sides, the power comes down. Natural log of x into natural log of x. Now the function has two parts, or we can say this is a function of, this is a function, or we can say this is a product function. That natural log of x is the first function and the second function is natural log of x. So natural log of y is a function containing a product of two functions. So taking rate of change of this function, which means that we have to apply the product rule here, because this is a function contains product of two functions. Here it will be 1 by y, because derivative of natural log of y is 1 by y into d by dx of y. Then by using product rule, derivative of the first function, so the derivative first function is 1 by x, the first function, into dx by dx, that is 1, and the second function natural log of x as it is, plus first function as it is, and this derivative of the second function, which means that natural log depends on this natural log of x, so this will becomes down, then d by dx of natural log of x. Again, while taking the derivative of this function, natural log of x, consider this whole thing as x, so 1 by x, which means that 1 by x, that is natural log of x, then derivative of this natural log of x. Now we only have to simplify this expression. This will natural log of x by x plus, this will be cancelled and we get only 1 here, so d by dx of natural log of x is 1 by x. Now because we only want to find the rate of change of y with respect to x, so d by dx of y is y will be on the other side, and it is natural log of x plus 1 by x, and we can write y in terms of x, that is given in the question, that natural log of x to the power natural log of x. So this is natural log of x to the power natural log of x divided by x, this x, and then natural log of x plus 1. So this is the rate of change of y is equal to natural log of x to the power natural log of x, and we have used the rate of change of natural log of x, we have used the property of log, we have used the product rule, and then we found the rate of change of y with respect to x. So by using all of the rules that we derive, and by using all of the rate of change of the special functions that are natural log of x, exponential function, logarithmic function with any base, and trigonometric functions, any other function, derivative is not a big deal of finding of any other function. So if you know all of the derivative of the functions, if you know all the rules, if you know all of the theorems, and so you can find rate of change of any of the problem. In the next video we will talk about higher derivatives, so stay tuned. Goodbye.